Okay, here we are. We want to replace letters with their alphabet position in this challenge from Codewars. Welcome. In this kata, you are required to, given a string, replace every letter with its position in the alphabet. If anything in the text is not a letter, ignore it and don't return it. Okay. A equals 1, B equals 2, etc. Okay, so we need to start at 1 for A. That's good to know. And here's their example. The sunset sets at 12 o'clock. Can a sunset set? Strange. Should return all of these numbers as a string. It looks like they're separated by spaces as well. So that's good to know. Okay, the first thing we need to do is figure out from a letter, find out what that letter's position in the alphabet is. So we are going to have to talk about the cur functions. Cur function and the ord function. Ord function. So cur, actually, let me just pull up a Python terminal here. Oh, I want Python 3. Okay. Let's say, what is ord of A? 97. Okay. And how about cur of 97? A. You see how that works? Ord takes a letter and turns it into its ASCII value, and cur takes a number and turns it back into a letter. And it's not necessarily letters and numbers. You can actually use this on anything. Ord of exclamation point 33. Cur of 33 exclamation point. So that's really useful, and I'd suggest taking some time to play with those functions together to figure out how they work. I forget, here's something I'm going to have to know. Cur, wait, as a string. Oh, okay. Well, here, let's figure out if lowercase a or uppercase a is greater. Cur of uppercase a, because we already know lowercase a. Oh, whoops, we need ord. Ord uppercase a 65. Okay, so that's telling me that in the computer's storage of, not storage, the computer's mapping of letters to numbers, the lowercase alphabet comes before the uppercase alphabet. So we can use this to check the position of a letter in the alphabet. But it's not quite going to be useful enough to know that lowercase a is equal to 97. We can make a little note about that. Lowercase a is equal to 97. Okay. Actually, this doesn't even matter, really. All we need to know is the letter's relative position to lowercase a. But we're going to need to turn all of the letters lowercase first, just to make sure that it all works correctly. So, yeah, let's work this out on paper first. What's a nice test string? How about A, B, C, D? That's nice and easy. So we know that the output of this should be 1 space 2 space 3 space 4. That's what the output should be. Ignore this little dot. That was my fault. So we have a couple of obstacles that are in the way here. if we just stick it in the or if we just stick it in the ORD function, it's going to give us 97 for little a, and then 98 plus 26 for b. Here, let's do that real quick. Where'd it go? Python. Python. Oh, it's here. It's here. Oop, there we go. ORD of big B, 66. Okay, 97, 66, 97, 99. What? Oh, the uppercase alphabet comes before the lowercase alphabet. Ah, my bad. So I said that before. I think I said it backwards. So uppercase before lowercase. 97, 66, 99, 68. And that's not really going to be helpful. But we can turn this a little more helpful if we just set all of these values to the same case. So let's do that first. All lowercase to lower case. That's going to give us A, B, C, D. And that simplifies our answer a little bit, because now we have 97, 98, 99, 100. But that's still not giving us the position in the alphabet. It's giving us the position in the alphabet plus 96. So what we need to do is subtract 96 from each of these numbers. So 97 minus 96 is 1, 2, 3, and 4. And that is going to give us our correct solution. Okay, let's see if we can do this in code. So first we need to put everything in lowercase. So let's do that. Our text is our string. So I'm going to say lower text equals text dot lower. I'm pretty sure that's the function in Python. Let's check that. Python string to lowercase. String lower. Yep, so dot lower. That's what it is. Awesome. So that takes care of this step right here. Check. Now what we want to do is get the ASCII values for each of the letters in the string. But we need to make sure that it is a letter before we care about it. So that's another part that we didn't talk about. Let's do that real quick. So ABCD, lowercase ABCD. What if we have A exclamation point CD? Here the correct solution is actually going to be 1, 3, 4, because we don't want to care about this exclamation point. But the nice thing about ASCII, here I'll show you ASCII table. Let's look at it. ASCII table, just give it to me. Come on. I'll open a new tab. There we go. We've got a whole bunch of characters here. The nice part is every letter is right in a row. From lowercase a to lowercase z, there aren't any weird characters in between there. All the weird characters are somewhere on the outside of the range of 97 and 122. So what we can do is check to make sure that our character, since we made sure that they're all lowercase, make sure that it is somewhere between 97 and 122. And if it is, then we can include it in our solution. And if it's not, let's see, what's exclamation point here? I know we just looked up, but there it is, 33. 33 is nowhere near 97 to 122. So we know we can just throw that out. Okay. There's our ASCII table. We have our lowercase. And oh, you know what? I think this might be good for a helper function, just to simplify things. So let's say def is letter. Is letter. Okay. That's going to tell us whether it is actually a letter. Yeah, I think that's useful. So C for character. What this is going to return is true or false, whether it is a letter or not. So if actually let's just say return. Return ord of C is greater than or equal to ord of lowercase a, and ord of C is less than or equal to ord of lowercase z. Okay. And I want to make sure that this always ends up being a lowercase, so let's just convert this to a lowercase letter in this check. So lower c, which means we actually want to use lower c here and lower c there. Okay. And if I were smarter, I would test this real quick, but I don't want to because I'm lazy. So we're just going to use the whole thing as a test, which is really not the right way to do it, but whatever. Okay, text.lower. What we want to do is loop through all of these letters, and if they are a letter between A and Z, then we want to get their relative position in the alphabet. So I'm debating whether I should make this another helper function. I think I should, just because that's the mood I'm in. So def get alphabet position for a character. And I am going to use this function with the assumptions. So I'm going to say assumes that C is assumes that is letter C returns true. Returns true. Okay. And there's probably different ways to ensure that. There's definitely better ways to ensure that that is what the case is, but this is just a little test game, so I don't have to over-engineer this. So let's say get alphabet position. So we can't assume that it is lowercase yet, so let's do the same lower c equals c dot lower. Okay, and then we're working with lower c now. So we want to return ord of lower c minus ord of lowercase a, and since they decided that a equals 1, that adds the little pain of we have to add 1 to fix our off by 1 error. Okay. So now all of our work is done, and we just need to put it together. So let's say for C in lower text, actually, I'm just going to skip straight to the one-liner. Let's return space.join. Ooh. Actually, I can't quite do that. How about map? I haven't really used the Python map function. Let's see. Python map function. Map. Okay, it takes a function and an iterable. Function to which map passes each element of the given iterable, and an iterable which is to be mapped. So, we can write a function that will take care of returning what we want it to return. And, how about filter? Yeah, we can use filter and map together. Python filter. Filter extracts elements from the iterable for which a function returns true. Okay. Check even. And since I don't want to have to make new functions here, I am going to learn about lambdas. So lambdas for Python. Lambdas for Python. Ooh, come on. Load for me. Come on now. You can do it. Okay, it finally loaded. Python lambdas. Lambda arguments colon expression. All right, let's put all this together with dot join. Here, let's actually do the lambdas first. So, our resulting list of numbers is going to equal n for n in lower text. I don't know why I used n. Let's use C, because that makes more sense. C is a character. C for C in lower text. Dot filter. Okay, filter, does the function come first? Yep, so the function's first. Extract. Wait, hold on. Oh, filter. Filter on the outside. Check even numbers. Okay. Yep. So let's use it that way. This is our array that we want to filter through. So let's do this. Filter. And here we want our lambda function. Lambda, let's call it char. Lambda char, colon, and we want to return is letter, char, is letter, char. Oh, you know what? I think this is already what we need. We don't even need a lambda for this. Let's just do this. Is letter. That's going to be our function that filters through. Perfect. Is letter, C for C in lower text. Okay. Resulting list equals this. And now we need to map it to the get alphabet position. So I think, does map work the same way where it comes first? Yep, I think so. So let's map get alphabet. Wow, spelling. Position. And then we're going to use the return value from this filter as the second argument in our map. Resulting list equals map. And now we can actually turn this into a one-liner. Return dot join this array of characters. Okay. Let's see if that works. Error. Get alphabet position. Oh, whoops. Okay, we need one more step here. We got to turn the numbers back into letters after the get alphabet position. Oh, you know what? We can just do that up here. Get alphabet position, return stir of this. Let's try that. Ooh, so we didn't quite get it right. 20, 8, 5, 19. Can you tell what's going wrong? We don't have the right separator. Let's put a space there. Test. Look at that. Test passed. Okay, let's get rid of my paper so you can see. So we passed all our tests. Let's try the attempt. Please work. Ooh, it's thinking real hard. Booyah. Passed 127, failed 0. Nice. Now, you could turn this into a one-liner, and you could do it without these helper functions. But I like helper functions because it helps things to be understandable and readable. And this is already confusing enough as a one-liner, so really even this isn't very helpful in actual development. So, but it works. Submit. Boom. There it is. And I will see you later. Goodbye.